Hey everybody, hope you guys are having an awesome Tuesday today. Hope you guys had a great week. Got outside a little bit. I know we had some rain, but that's okay. Um, but hopefully you guys are ready for another awesome week of science class here. All right, so on Thursday what we did was I gave you guys a survey to do. A lot of people got that done. Very good. Uh, got some great advice for ways we can move forward. Okay, so some of the advice was more home labs. Okay, that's what we're going to do today. Sound good? All right. Another one was explanation about assignments and video. All right, so I'm gonna work on that. Okay, that's a good one. Go over homework. Go over more math problems. I know that the math was a little difficult, talking about Planck's constant. But as we move forward, I will definitely go over more math problems, or explain it a little bit better, okay? But on a bright side, man, you guys are hilarious. Holy smokes. I was reading your all's jokes, and you guys had me dying laughing. Let me see if I can read some here real quick. Now, a lot of them were like, they were okay. Some I could tell were off Google, but man, there's a few that I've never heard before, and they kind of got me going. One says, "Why shouldn't you iron a 4-leaf clover?" Because you don't want to press your luck. That's a good one. That's a good one. Why did the Scarecrow win an award? Because he was outstanding in his field. That's a good one too. It's a good one. What's a cow with no legs? Ground beef. I feel like a lot of these are dad jokes, and I love them. And then there's one there was a few good chemistry ones. A neutron walks into a bar and asks the bartender, "How much for a drink?" The bartender says, "For you, no charge." That's a good one. Neutrons don't have any charge. Oh man, there's a lot of them. You guys made my day. That was good. That was funny. Good to watch. Okay, so today we are going to finish up electromagnetic spectrum. Okay, we're going to be talking about the most important one, visible light. I should have pressed my eyes, I guess. Visible light. And we're going to be doing activities today, and then we'll be moving on. Next week we're going to move into a little electricity unit. Okay, so a little bit of electricity currents. We'll see how that goes. Okay, so first I'm going to introduce like some light stuff. I know most of this might be a review, and that's okay. All right, so I'm going to share my screen here. There we go. All right, so light waves. All right, here we are. All right, so light. All right, there's a reflection and a refraction. So reflection, okay? You don't have to write this down. It'll always be in this video, but smooth surfaces reflect light rays in one direction, okay? So light ray goes down at an angle, it's gonna go back at that angle, all right? Or, yeah, you see the picture, okay? And rough surfaces might vary, all right? It might go down and then it might go up. It just depends on the angle of the rough surface, okay? That's what reflection is, all right? Kind of like a mirror. Mirror's a reflection, right? Oh, here's a good example, all right? Mirrors have smooth surfaces that the light reflects well enough to create a virtual image. So if you look into a mirror, see it coming right back at you. That's pretty cool, okay? Then there's refraction, all right? So light has reflection, refraction, all right? Light refracts or changes an angle, okay, when it passes from one medium to another. And the best example is air going into water, okay? If you look at the cat thinks it sees a fish going at a straight line. However, the fish is actually a little bit lower than what the cat actually sees. So object appears in a different position. One way you guys can do this is bending light with a pencil. What you can do is take a pencil, drop it in water, like a cup of water, and look at it from a side. All right, it actually looks like your pencil's bent, like you broke your pencil. All right, so if you drop this in a clear glass of water, you'll see it. You'll see it. That's pretty cool. And that's refraction. Okay. And how you can get these is different types of lenses. Okay. You've probably seen many of these lenses before. All right. Lenses are a curved piece of glass that refract light waves. Okay. Causing a different change in direction. Okay. So there are things known as convex, where light comes all together. And then there's things that's concave, where light spreads out. Okay. Some examples of convex. Convex comes together. A magnifying glass, that's convex. Binoculars, all right, brings light in. Those are convex as well. Some examples of concave are flashlights and eyeglasses. Eyeglasses, those are concave. And I just went over that, okay. And prisms, all right. Prisms are the central of visible light, all right. If you shine light through them, they'll actually show the entire electromagnetic spectrum, or all the colors of visible light, which is pretty cool, all right. All right, so hopefully that's a little review, a little background of what the topic is about. Okay, so now we're going to do activities today, one of two. Okay, I know hopefully everybody in their house either has a mirror and a pencil. If you got that, you're great. So what I'm going to do is I'm going to describe the activities here for a second. Okay, so I'm going to share my screen, and so I can describe the activities. All right, so there are two options. You only have to do one of them. Okay, you only have to do one of them. Okay, option number one, explore how mirrors reflect light to create a virtual image. All right, what is a virtual image? You'll have to Google that. All right, draw an image and explain how a mirror creates a virtual image. Okay, so draw a unique picture and explain how it does that. All right, and then here's the procedure. Okay, you can just keep your time on your phone. All right, start a timer. So you might have to print this page out. That would be the easiest way to do this, to draw a star. If not, just try tracing this on your computer from a piece of paper. That would work as well. Like just place a piece of paper up on your computer. And the directions are pretty straightforward. When you're done drawing, stop and record your time. All right, this is where you record your time and adjusted time, okay? And this is just to show you virtual, all right, virtual images. So when you get that done, all right, just fill in the numbers here. I tried this myself. I wasn't too good on the mirror part. It was very difficult, but I'm sure you guys will do awesome on it. And then the second activity, draw images of convex or concave lens and what happens to light rays when they pass through these types. All right, you can either Google that or just rewind the video about a minute and a half. Okay, now on this one, you need a convex and a concave lens, which might be actually difficult to gather. Okay. And that's okay. That's why I'm only requiring one of these activities, okay? And I try to explain these in pretty good detail while staying several feet from the windows. Hold a convex lens between the window and the index card. So you have to get a window. Hopefully light shining in on that window. That would be best. All right, yeah. And then just follow the directions. This one's actually pretty cool. I personally wasn't able to get good results. I didn't have a magnifying glass, so I tried using the end of a flashlight and my glasses I wear as my convex and concave lenses, and it didn't work that well. I think if you had a magnifying glass, that would work best. And for some reason, I don't have one here. I know I have one at school, but that's okay. So follow those directions. I hope you guys would get, those that who do this one, I hope you guys get awesome results. I really want that this is a fun activity. I've done it before and it works really, really well. All right, so there's that. You only have to do one of these two options, okay? And I hope you guys get some good results, all right? From this visible light, that's kind of the central of the electromagnetic spectrum, right? It's right in the middle, all right? It's the main event, all right? And that's the last thing that we're going to cover for the electromagnetic spectrum, light. Light, we talked about waves, all right? That this all ties in together. But we're not gonna have a quiz over this. We're actually going to move on to the next topic. The next topic for next week is actually going to be electricity. Okay, we're going to talk about electricity, currents. So yeah, all right. Guys, you are awesome. You guys gave me a lot of advice. When we move forward, as we move forward, all right, I'll work on my providing a good virtual school experience for you guys. But anyway, if you have questions, let me know. I'm always here for you guys. I do have those office hours. If you ever have questions, shoot me an email. I try to respond as fast as I can. Guys, you are awesome. Have a great day. We'll see you on Thursday.